Hello, welcome to Chapter 19 for Business Math called Financial Management. This is Lesson 19.3 called Borrowing. As always, when I'm doing these videos, make sure that you are reading through the chapter, looking at the examples, paying attention to not just how do I get through this problem, but what am I doing? Why am I doing it? The more you understand about what you're doing, the better you're going to be able to apply it throughout not only this section, but throughout the chapter. So just make sure you're paying attention to all that before jumping over to these worksheets. All right, so the little summary here is your business may take out a commercial loan to buy raw materials, products, or equipment. The maturity value of your loan is the total amount you repay. Commercial loans usually charge ordinary interest at exact time, and they're giving us this little clue. Sorry, there's a bad circle. There you go. So 360-day year. So there's 365 days in a year, but when we're using ordinary interest at exact time, we do it a little differently. We do it with 360. It just kind of evens out the months a little bit more. It's basically kind of what it does. Interest equals principal times rate times time. This is not the first time we've used this one. This is very simple interest formula. Make sure that you're paying attention. Time means days that they will give us over 360. That's what time means. We need to know how many days out of the year, which we're saying is 360 days, are we actually using or are we calculating interest for? So that's actually a big piece of this. Maturity value equals the principal, what you took out originally, plus any of the interest that you owe. So use ordinary interest at exact time to solve the following problems. So we're going to look at number one here. We have $90,000 for our principal, an 8% rate, and time in days is 180. So when I look at this, I know it's principal times rate times time. Remember, time is divided by 360. 360, so I got to press a little harder on my board here. So we want to make sure that we're paying attention to that. So the other big piece here that I see students doing all the time is not doing the percentage. So they'll just do 8 instead of 8%. Remember, this doesn't mean 8. It means 8%, meaning a decimal. So it actually means 0.08. That's what 8% means. So make sure you move that decimal. You can also use a calculator. If you type in 8 and then hit the percentage symbol on most calculators now have them, it'll move the decimal for you. But just make sure move that decimal or you're not going to get the right answer here. All right, so if I multiply 9,000 times 8% times 180 divided by 360, and if you go from left to right on this one, it should still work out just fine. The interest will be $3,600. And so here, really quick, I'm going to, wrong computer there. I'm using the wrong mouse. I was going to grab a calculator and just show you what I mean on the percentage. So if I'm looking at this calculator here, I have 90,000 times 8%. So that, it didn't show you moving it, so I'm going to do it without this. So 8%. Now it shows that percentage. What it did right now is it went times 90,000 and it multiplied it automatically. It just went ahead and did that calculation. Some calculators will continue to show you the whole calculation, but I know my Apple one doesn't necessarily do that. It just goes ahead and calculates it. So it just moves forward. And then, times 180 divided by 360, and I get my 3,600. Okay, so just be aware of how that works on a calculator, depending on which one you're using. And I've seen students use one on the internet where it keeps the calculation going for you. I've seen that happen on some of the other calculators too, some of the older kind of ones that we used to have in classrooms. But for whatever reason, my Apple one doesn't do that. Androids, I think, are pretty good about showing you the calculations. All right, anyway, maturity value is just you add the principal and the interest. So here's my principal, here's my interest. I'm going to add those two together. So I get 93,600. That's my maturity value. Do not round off your dollars here. So, if you have change, in this case, it would be, 0, 0, there's no change on this one, but don't round off your change. You don't want to skip out on if this was money that you were borrowing and getting paid back, you want to get all the money that you were entitled to get paid back based on the agreement of the loan. So don't knock off, change there just because it's a little easier to write. Keep it there unless it told you to round to the nearest whole dollar. I'm saying that because I have students who have just recently done that kind of thing. All right, so if we look at any of the word problems here, they're all pretty much the same idea. So Maine National Bank loaned $58,000 to White Mountain Lumber. The term of the loan was 180 days. The interest was 10.5%. What was the maturity of the loan? So we do principal times interest times time, remember, divided by 180. And that'll give me my interest. Okay. The actual amount of interest, not the interest rate. Don't confuse those two. And so now that I have my interest, I can add that to my principal. So when I do principal times rate times time, I'll get my interest amount, the amount of money that I'm going to pay for interest. And I'm going to add that to my principal, what I took out to begin with, to get my maturity value. All right, so I'm going to let you guys work these out. The only one I kind of want to focus on for a second is number 7, and then we'll look at the algebra one here. So Open Door Company needs to borrow $380,000 for 180 days to help finance the production of a new model door. The business manager arranged for financing from 2 sources. Each loan charges ordinary interest at exact time. The prime rate is 2.25%. So they do not explain prime rate anywhere on this page. So I want to take a moment to explain this. Number 1, this is a good reason why we should pay attention to the chapter, because the chapter does explain this. So we definitely want to understand what prime rate means. So this is basically a good starting point for customers' rates. So sometimes it'll be over this amount, sometimes it'll be under this amount, depending on if it's a really good customer and they want to give them a little bit better rate. But prime rate is kind of a starting point, if we think of it that way. So when we look down here, it says Georgia Trust Company is going to do $134,000 for 180 days, interest rate 2% over prime. Pay attention, it's not a 2% rate, it's 2% over prime. So if prime is 2.25, then they're going to do 4.25 because 2.25 plus 2 more, 4.25. Okay. So what is the total interest for 2 loans? It's not giving you all enough space here. You're going to have to end up calculating it somewhere else. But you want to do principal times rate. Remember, it's 4.25. That's your interest rate times days or time. Don't forget to divide by 360 to correct it, because otherwise you're going to have this ginormous number you don't want. And that'll give you the interest rate for Georgia Trust. They want both. What's the total for 2 loans? So now I'm going to do the same thing. Peachtree Investment Company, they're going to give us $246,000. And guess what? If you add $246,000 and $134,000, you get $380,000. They add together. Craziness. So we want to take our principal, our $246,000, multiply by our interest rate and our time. So here's our time, 180 days again. And this is 3% over prime. Again, it's not 3%. It's 2.25 plus 3%. So it's 5.25%. So that's definitely one that I've seen kind of mess some students up. They're not really paying attention to what to multiply by, so they don't end up getting the correct number. You'll get kind of close-ish if you get. It's kind of funny because it does end up averaging pretty close out to like 2 to 3%, but which is interesting because they're both over that. But if you do the calculations without adding this, it's not quite right. It'll be under. So we definitely want to make sure we do these calculations. So you're going to do both of them and add them together. You're going to get a total. And that'll be part A here, your total interest for both. What's the maturity value? So you're going to add them together. Guess what? They already add together to get 380. I already know what my principal was. or my original principal. And then I'm going to add 380 to the interest that we just calculated, and that'll tell you the maturity loan. All right, so let's go ahead and take a look at this algebra problem. I'm going to scooch this up and give myself a little bit more room here. And I'm going to erase this bit here. Get rid of this just to give me a little bit more room to write. Okay. So the Golden Gate Construction Company was able to obtain a subprime loan at 1.5%. So subprime means below prime, sub. That's the wording there. The prefix means below. And they even give you another word here, below prime. So subprime loan at 1.5% below prime. They're really letting you know it's below the prime interest rate. The principal of the loan was $4.65 million for 8 years. Find the prime rate if the maturity value of the loan is $6,184,500. All right, so we're going to definitely need to set this up a little bit. We need to think about how this all calculates together. So if we look at these pieces, let's see. I want to set this up, in a way that definitely makes sense. So first, we have principal times rate times time. That's kind of our basics here. And remember, don't do 4.6 million. You want to actually expand this out into a full number. So we want to do 465,000. So 4,650,000. We want to make sure we expand it all the way out. So this is principal times rate. So it's going to be my prime rate, which I'm going to do is a P, minus 1.5%. Because remember, it's subprime or below prime. Again, they told us that twice. So this is my interest rate. I don't know what it is yet because I need to know what prime is. That's what they're asking us to find. And then I'm going to multiply this by my time. So my time is 8. And since it's a whole year, I don't have to do the divide by 360. I can just say times 8 because it's going to be the full year. The only reason we have to divide by 360 in some of the other ones is days. We're doing partial years. So if it's just the full year, I can just multiply by the number of years. Makes it a little bit easier there. I want to make sure, because this is how I calculate interest rate, principal times rate times time. The 6,184,500 includes the principal. So this is the maturity. In order to get maturity, I have to take my interest and add my principal to it. So I'm going to add my principal back to this. So again, this is my interest. This is my principal. And you get maturity by adding interest and principal together. So I'm just trying to make that very clear what I'm doing here. And that's going to equal my maturity value of 6,840,500. All right, we have an equation built. So this one's definitely takes a little bit more understanding to get here. It's not necessarily, I don't think, terribly difficult, but you have to understand, how do I build the interest formula? And then how do I get from here to here? Okay, I have to add my principal to get from interest to maturity. So you really need to understand how to put all of this together in order to get to this point. So now we need to start kind of simplifying a little bit here. And what we want to do is, the first thing I did was I distributed this 4 million here to both of these. So I end up with 4,650,000 P minus, and if I do this 4,650,000 times negative 1.5%, remember it's a percentage, I need to move this over. It's not 1.5, it's 1.5%. So it's a little different. So if I multiply those two together, I get 69,750. I'm still multiplying by 8 here. I'm still adding 460,000 500, and that still equals 6,184,500. So I need to distribute one more time, and I'm doing this in pieces just to hopefully it's not confusing. There's a couple of different ways that I could have done this. For whatever reason, I decided on the distribution here like this. So I'm going to distribute the 8 now from the other side. Doesn't matter which side of the parentheses the number is on. You still distribute or multiply it by everything inside of there. Just like I did with the 4 million in the front, I did the same thing with the 8 million in the back. So I'm going to multiply by 8, and I'm going to end up with a really big number here, 37,200,000 P. Oh, missed a 0. Minus, this also gets multiplied by 8. So I end up with 4,092,000. And that's minus, because it was minus to begin with. Oh, nope, sorry. I was looking at the wrong line here. Ha ha ha. That's after I combine these two. This is 558,000 negative plus, and I'm just bringing this down, 618,500. Okay, so now we're getting a little bit more simplified. We're getting there. We need to add our like terms together here. So that's actually where I get the next piece from. Whoop. So I'm going to rewrite 37,200,000 P equals, I'm combining these two amounts, so that gives me positive, I don't know, I put an equal sign there, positive 4,092,000 equals 168,500. And just because I'm totally running out of room here, I'm going to do a little tricky thing here. I'm going to, woo, that was way too much. Let me make that big. I'm just going to give myself a little bit more room here. I'm going to move all this stuff up. Okay. So kind of a silly way to do this, but it helps just a little bit because I'll be able to finish the problem here. Okay. So I'm going to rewrite just what I have down here because I'm kind of getting crammed in. P plus 4,092,000 equals 6,084,500. Okay. So again, I just rewrote this one. I haven't changed anything again. I just was rewriting it up top so I had more room. So now, other than the fact that these are huge numbers, this looks a bit more simplified. Now I need to start solving for P. I need to know what my prime rate is. So I want to undo what's being done on the same side as my variable. So I'm going to look for addition and subtraction first. So I'm adding 4,092,000. I'm going to subtract that from both sides here. Like that. And then my 37 million, oh, I keep doing that today, comes down. This cancels out any number minus itself. Doesn't matter what the number is, how big, how small, any number minus itself cancels. And it can be positive on top, negative on the bottom, or it can be negative and positive. As long as they are the same number and opposite signs, they cancel out. It's a guarantee. And that's what we wanted because we want to move it over to this side here. So when we subtract this, we end up with 2,092,500. So we're definitely getting a bit smaller here. So our last step, we need to deal with this multiplication that's happening here between the 37 million and the P. So we're going to divide by 37 million on both sides of the equation. Remember, whatever I do to one side of the equation, I have to do to the other side. Any number divided by itself, just like any number minus itself, cancels out. This becomes 0, which we don't have to write 0 here because it goes away. Anything plus 0 doesn't change. This doesn't become 0 when we divide. It becomes 1. And I don't have to write 1p. I can just write p. Equals, and now I'm going to do my division here. So I'm going to let you guys go ahead and finish that one off. This is the last piece here. You can definitely go ahead and finish the calculation off. This is going to give you a decimal. Make sure you multiply by 100 to move that over so that we know what the percentage is. So make sure multiply by 100 once you divide this and get your actual percentage, because they're looking for the prime rate, which is a percentage. All right. Well, that was section 3. I hope that helped, and I will see you in section 4.